question I'm going to teach that will be involved in your term test. Okay, so let me check, have I started recording? I think I did. So 2Q. Week 4, Thursday. So the agenda for today is we are going to look into acceleration of a point within the rigid body. This diagram that I'm showing is available online. I think it was last Tuesday's lecture. Okay. So as you can see, what we have over here, right, is this is what we call a rigid body. For this chapter, anything that you see cloudy in space, that's a rigid body. And I wrote this before, is that we have a tangential. Let me zoom in a bit more, then you can see better. You have a tangential component of acceleration. And this defined as AT is equal to alpha R. Okay, alpha being angular acceleration, and R over here, as you can see, is the radius. Okay. So we also know that AT is equal to 0, okay, if the speed is constant. Okay, so acceleration is equal to 0 when the speed is constant. So we can see over here in this figure, this is AT, this is a point. Let me change color, do apologize. This is a point where it's point P, and at the tangent of that point is your acceleration in tangent component. Then the next one, we have normal component of acceleration. Okay, and I think I will highlight this up. And AN, we call it AN, is equal to omega squared R. Okay, where we know that omega is our angular velocity and is in radians per second. Okay, a key thing to take note is AN is always pointing towards O, okay, which is center of the path. Okay, center of the path. So if we write out the term acceleration, this is equal to dv over dt. We know that, right? And we also know, note that velocity is equal to omega r. Okay. So with that in mind, I do apologize. I'll move this way elsewhere first. Okay. So now if we were to substitute V into this component over here, you have d omega r over dt. So this can be written as d omega over dt multiplied by r plus by omega cross dr by dt. I could not remember my differentiation. Is this called product rule or something like that? Could you remember? Yeah, whatever. Okay, as soon as you know the steps, I can't remember that. I do apologize. So we are aware, right? We are aware that alpha, okay, we are aware that alpha is equal to d omega over dt, right? We know that, and we also know that dr over dt, right, is equal to your velocity, and this is equal to omega cross r. Okay. So we are going to substitute this term over here into here, and we're going to substitute this term over here into here. So at the end of the day, our acceleration term is equal to alpha cross r plus by omega cross r. Okay. Now this is not multiply, this is cross. Okay. So we are later on, we are going to deal with this aspect. Okay. And if we were to write this out in terms of A is equal to AT, right, plus by AN, then the above formula will be equal to alpha cross R minus omega cross R. Okay. Why it is minus is because AN is pointing towards which direction? Into, okay, into the center. Pointing out from the center is positive, pointing towards is what? Negative. Are we clear? Right? So this is, if you ask me which formula to focus on, I would say focus on this formula more than anything else. Okay. On that context, okay, we both know our tangential and our normal acceleration. Okay. So acceleration in magnitude, so we are just considering the magnitude, can be determined from A is equal to AT squared plus by AN squared. Okay, we just want to find the magnitude. We could substitute into there. Okay, now I'm going to show you one example, and this example I'm quite nervous because I keep on making mistake on this example. Okay, and I have devised a way so that if you follow this method of approach, I told you guys I'm communist, right? You won't make that mistake. Okay, and it's really straightforward. Okay, but the procedure can be tedious, so bear with me. Right, let's look at this. So this is one of the most difficult examples in your homework. Sorry, in the textbook. Okay, and I always look for trouble. Okay, let's give them something tough. Right, but I hope by 4:20 you guys are ready. Okay, it's not that bad. Okay, so let's look at this example. This example will take 1 hour. Okay, if I don't screw it up. So what you see over here is the shaft and plate rotate with an angular velocity of omega 14 radians per second and angular acceleration of 7 radians per second squared. We have asked to determine the velocity and acceleration of the point D on the corner of the plate of this instant express the results in Cartesian format. Okay. So we have to find what is going on in point D. Before I go on, okay, let's look at something. All of us are very familiar with forces, yes or no? Right, all of us. So you guys are doing 2P. I'm going to do something familiar to you guys first, okay? So let's consider forces. Okay, so if this is my X and this is my Y, right? And I have a force applying in this direction. Okay. And this force is, for example, 8 kilonewton. Okay. So we know given distance, okay, so so this force, right, the orientation based on geometry is we know two distance. The distance from here to here is, for example, 6. The distance from here to here, just for example, this is 10, right? So if we want to find our components, we want to find what is our Eugene, come on, what's wrong with you today? If we have to find out what is our fx and what is our fy, there are two ways of doing this, yes or no? Did Dr. Koshi go through this already? Right, there are two ways of doing this. So one way is to use what we call similar triangles. Because based on geometry, in fact, both are based on geometry. If we were to construct this, we know that the distance from here to here is 6. The distance from here to here to 10. So the distance from here to here is equal to 10 squared plus by 6 squared. This will be equal to what? 10 squared. 10 squared plus by 6 squared square root. It's equal to 11.662. Right? So we can find that if we do 6 over 11.662, this will be equal to Fx over 8 kilonewton. Can you see why do I call it similar triangles? Yes or no? Right? You put 6 over here, right? 6 is equivalent to your Fx. 116.2 is equal to your resultant 8 kilonewton. So from here, Fx is equal to 6 multiplied by 8 times 10 to the power 3 divided by 11.662. So 6 times by 8 to the power 3 divided by 11.662 is equal to 4.116 times 10 to the power 3 Newton. So for us to find Fy, is the same, right? So similar triangles again. Now this will be 10 multiplied by 8 times 10 to the power 3 divided by 11.662. So this will be equal to 10 times by 8 power 3 divided by 11.662. So you got 6.60, 6.668, 6.60 times 10 to the power 3 Newton. Another way of doing it is to find the angle, right? So by using the angle theta, so if I'm going to call this angle theta, so we know that tangent theta is equal to what? Based on geometry, is again 10 divided by 6. So therefore, theta is equal to, so I'm going to change it to degree. Okay, so 10 divided by 6 inverse tangent is equal to 59.03. 0.04 degrees, for example. So to find Fy is equal to what?